So over the last couple of lessons, we've been investigating dividing with just integers, and today we're going to jump into what happens when we divide some rational numbers. Rational, the root word again is ratio, and ratios look like fractions, so a good place for us to start is with the division of fractions. We're going to take a look at a few problems here and see if we notice some sort of a pattern that's happening. In the first question, it says that there are 3 candy bars to share. Each person is going to get 1/4 of a candy bar. How many people will get a piece of candy? And you'll see here that I've got my rectangles here that are representing my 3 candy bars. And what I'm going to do, I'm taking my 3 candy bars, and each person is going to get 1/4 of a candy bar. So I'm going to be dividing my candy bars into pieces that are 1/4 of the candy bar size. Okay, and I want to know how many of those people will be able to get 1/4 piece of a candy bar. So I'm going to take my 3 candy bars, and the first thing I'm going to do is cut them into fourths. So the way I like to do that is cut them in half first, and then I cut my halves in half. And do your best to try to make these look as equal as possible. Okay, so there's my second one cut into halves, and I'm going to take my third one, and I'm going to cut that one in half, and cut that half into half. All 3 of my candy bars have been cut into fourths, all right? Each person is going to get 1/4 of the candy bar, so I'm going to count up how many 1/4s there are in my 3 candy bars. Well, I see here there's 1, 2, 3, 4/4 in this candy bar, and there's 4/4 in this candy bar, and there's 4/4 in this candy bar, so that makes a total of 4, 8, 12 people that would be able to get a piece of candy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 divided by 1/4 is going to have a value of 12. In the second example, again, I have 3 candy bars to share. This time, each person is going to get a half of a candy bar. How many people would get a piece of candy this time? So again, I'm going to take my 3 candy bars, and I'm going to divide them into halves, and I'm going to see how many people would be able to get a piece of candy. So here are the 3 candy bars. Cut each one in half. Okay, and then how many halves are there in the 3 candy bars? How many people would be able to get a half a candy bar? Well, there's 2 halves here, 2 halves here, and 2 halves here. 2 plus 2 plus 2. That's a total of 6 people that would be able to get a piece of candy. 1, 2, 3, 4, 5, 6 halves in my 3 candy bars. Okay, well, again, now in number 3, I have 3 candy bars that I'm going to share. And this time, everyone's going to get 1/3 of a candy bar. So how many people would get a piece of candy in this situation? So again, I'm taking my 3 candy bars, and I'm going to cut them into thirds, and I'm going to see how many people would be able to get 1/3 of the candy bar. So let's take our 3 candy bars and cut those into thirds. Okay? And again, make sure that you're doing your best to try to make them look like they're equally sized pieces here. There we go. Okay, so I'm going to count them up. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 thirds in my 3 candy bars. So 9 people would be able to receive 1/3 of the candy bar. Okay, and so in the box down here, it's asking what we noticed. So I'm going to write down each division problem. In the first division problem, I had 3, and I divided it by 1/4, and that was equal to 12. Well, hopefully you see that there's a connection here between this division problem and a multiplication problem, whose fact that you already know. 3 divided by 1/4 equals 12, but also 3, all right, I had 3 candy bars, and in each candy bar, there were 4/4, 4 pieces. So if I took my 3 candy bars and multiplied it by 4, which was the number of pieces in each candy bar, that also gives me the value of 12. 12 people would be able to get a piece of candy. It works with the other examples as well. Our second example, we took our 3 candy bars and we divided them into halves, and we saw that 6 people were able to get a piece of candy. Well, again, if I take my 3 candy bars and I multiply by how many halves there were in each piece, there were 2 halves, we can see that, 2 halves in each piece here, that also gets me to the number of people, 6, that would be able to get a piece of candy. Same thing with my last example. We took our 3 candy bars and cut them into thirds, and we saw that 9 people would be able to get a piece of candy. And that's the same if I took my 3 pieces, or my 3 candy bars, and multiply them by how many thirds were in each candy bar. There were 3 thirds in each candy bar. 3 times 3 is going to give me a value of 9. In my next example, I'm going to have 4 candy bars this time that I'm going to share, and each person is going to get 2/3 of a candy bar, and I want to know how many people are going to get a piece of candy this time. And instead of drawing out my picture, I want to see, can I just solve this mathematically? So what I'm going to be doing, I'm going to be taking my 4 candy bars. All right, let's take the 4 candy bars, and we're going to divide them into pieces that are going to be 2/3 of the candy bar each. So we need to figure out what is 4 divided by 2/3. Well, if you remember, in the examples that we just did on the front, we saw that the division problem was related to a multiplication problem. And if I flip back to what we saw down here, again, 3 divided by 1/4 was equal to 12. That's the same as 3 times 4, okay? And remember, you could take the number 4 and you could make that a fraction if you put it over 1. So 3 divided by 1/4 is the same as 3 times 4 over 1. Same thing with this example. 3 divided by 1/2 is the same as 3 times 2, which is the same as 2 over 1. And 3 divided by 1/3 was the same answer as if we did 3 times 3, and again, I could put that 3 over a 1. So what I'm doing here, I'm essentially keeping that first number the same, and instead of dividing, I'm going to multiply by this fraction kind of flipped over. You see how it's kind of, now this denominator became the numerator, this numerator became the denominator. Well, if I do that on this example here, this is going to change into 4 times, and now I'm going to take this number here, and I'm going to make this denominator the numerator, and this numerator the denominator, and I'm going to see what I would get when I multiply it here. Well, remember, I can make this 4 a fraction by putting it over 1. So it's really 4 over 1 times 3 over 2. And if I multiply my numerators, 4 times 3 gives me 12. Denominators, 1 times 2 gives me 2. And now this is 12 divided by 2, which is equal to 6. And so we know that 6 people would get some candy. If I took my 4 pieces of, or my 4 candy bars and divided them into pieces that were 2/3 of the candy bar each, 6 total people would be able to get a piece of candy. And so what I want to realize is here is that there's a relationship between this number 2/3 and this number 3/2. 2/3 and 3/2 are called multiplicative inverses, okay? And another word for multiplicative inverses is called reciprocals. Reciprocals, okay? 2/3 and 3/2 are called reciprocals. In order to find the reciprocal of a fraction, you just switch where the numerator and the denominator are located. So for this example on 2/5, well, it's reciprocal. I'm just going to switch the numerator and denominator. The reciprocal is going to be 5/2. For negative 3/4, well, again, I'm still going to be negative, but now I'm going to switch where the numerator and denominator are. The reciprocal of negative 3/4 is negative 4/3. The reciprocal of 10/7 is just going to be 7/10. And the reciprocal of 8, remember that's 8 over 1, the reciprocal here is going to be 1/8. And so when we come to a problem where we're dividing fractions, instead of doing the division problem, all we really need to do is multiply by the reciprocal of the divisor. I'm going to multiply by the reciprocal of the divisor. Okay, and that's going to make this an easier problem to do. We've multiplied fractions in the past, so we're really good at that. So we're going to take our division problems, and we're going to rewrite them as a multiplication problem. Again, we're going to multiply by the reciprocal of the divisor. And so in this first example, I have negative 3/5 divided by 12/25. Well, instead of doing this division problem, I'm going to rewrite it as a multiplication problem. The negative 3/5 is going to stay as negative 3/5, but I'm going to multiply by the reciprocal of my divisor, all right? Instead of 12/25, I'm going to multiply by 25/12. And now I know how to do this multiplication problem. Before I multiply, however, I'm going to look and see if I can simplify. And I know I can simplify with a numerator and a denominator. This numerator 25 and this denominator 5 have a common factor of 5. 5 goes into 5 once, 5 goes into 25 5 times. All right? This 3 and this 12 have a common factor of 3. 3 goes into 3 once. 3 goes into 12 4 times. Okay? And now I'm ready to multiply. My numerators, 1 times 5 is 5. My denominators, 1 times 4 is 4. I look back at my original problem and I realize that the numbers have different signs. When we divide numbers with different signs, we must get a negative quotient. So we end up with negative 5/4, which we can rewrite as a mixed number. 4 goes into 5 once, with 1/4 still left over. And don't forget that your answer was negative. And so the answer to this problem here is negative 1 1/4. In this example, I'm going to be dividing a couple of mixed numbers. I have 2 1/3 divided by 3 1/2. And if you remember when we were multiplying mixed numbers, the first thing that we did with our mixed numbers was rewrite them as fractions. And that's exactly what we're going to do here. Our first step when we're encountering a problem like this, we want to rewrite as fractions. Okay? Always rewrite your mixed numbers as fractions. And so I'm going to take a look at each of these. 2 1/3 is going to be equal to 7/3. And then I'm going to divide that by 3 1/2, which as a single fraction is going to be 7/2. Okay, and already my division problem is looking like what we were just doing on the previous page. From here, we're going to follow the steps that we followed on the previous page. Next, what we're going to do, instead of doing this division problem, we're going to multiply by the reciprocal. We want to work with a multiplication problem instead. Multiply by the reciprocal. Okay, and so I'm going to take my 7/3. That's going to stay as 7/3. But instead of dividing by 7/2, I'm going to multiply by the reciprocal, which ends up being 2 7ths in this case. Now it's a multiplication problem, but before I multiply, step 3, I'm going to simplify if possible. Simplify if possible. And looking at these fractions, I see that I can simplify. This numerator 7, this denominator 7, they have a common factor of 7. 7 goes into 7 once. The 2 and the 3 don't have any common factor besides 1, so now I'm ready to do step 4, which is just to multiply. Multiply. Well, in my numerators, 1 times 2 is 2. In the denominators, 3 times 1 is 3. And so the answer to this question, 2 1/3 divided by 3 1/2, the answer is going to be 2/3. I know it's positive because these numbers had the same sign. In question 12, I'm told that on Saturday, Lindsay walked 3 1/2 miles in 1 2/5 hours. I want to know what her pace was in miles per hour. Miles per hour. So if we think of that, miles per hour, it's kind of like a division problem there. Miles being divided by hours. And so I'm going to take my miles, my 3 1/2, and I'm going to divide it by the number of hours, which was the 1 2/5 hours. So this is the division problem that I'm going to have to do in order to answer my question. Well, I'm just going to follow the steps that I used up above. I'm going to change each of these numbers into fractions first. 3 1/2 is the same as 7/2. And I'm going to divide that by 1 2/5. That's going to turn into 7/5. And now what I'm going to do with this, instead of doing this division problem, I'm simply going to multiply by the reciprocal of the divisor. I'm going to keep 7/2 the same, and I'm going to multiply not by 7/5, but by 5 7ths. Okay, and now with this multiplication problem, I'm going to look and see if I can simplify first. I can here, these 7s have a common factor of 7, which turns them into 1. The 5 and the 2 don't have any common factors, so now we're going to multiply, and we're going to end up with 5/2. Well, 5/2, 2 goes into 5 2 times with 1/2 left over. And so the meaning of this answer here, since the answer is 2 1/2, we're going to write that Lindsay's walking pace is 2 1/2 miles per hour, and we can use the abbreviation MPH for miles per hour. Lindsay's walking pace is 2 1/2 miles per hour.